Hello everyone, we are team Gameis Alive, presenting you our solution for the theme AI-powered API anomaly detection and monitoring system. So basically, all the modern applications are distributed systems. Distributed system consists of multiple microservices, which is a small independent components which work together. So each microservices can have multiple instances, and it can be deployed in any environment like on-premises environment, cloud environment, or even multiple cloud setup. When a user requests an API, it can flow through more than 10 plus microservices across different environments. But when an API slows down or fails, is it a problem with one faulty instance? Is it a problem with API? Is it a problem with a complete microservice? Or is it a problem with the environment? Even worse, finding the root cause. Whether this happens because the anomaly has happened because of high CPU usage, memory leaks, network bottlenecks, or bad deployment. Without clear visibility, teams waste hours digging through unstructured and unformatted logs and metrics, struggling to connect the dots. This is where our system comes in. So this is the system design or a solution we have come up with. So the first task is unified data collection. So we start by instrumenting every layer of our system. Our OpenTelemetry collector aggregate traces, metrics and logs across all environments. It auto-discovers new instance, ensuring no microservice, container or virtual machine goes untracked. Second step is cleaning and standardizing. The raw data flows into Logstash where we enforce schema consistency. For example, if AWS has a parameter latency and on-prem server has response time, to make this structure unified, we make this field duration millisecond. Data is tagged with contextual metadata, service version, instance ID, and stored in Elasticsearch for lightning fast queries. Now comes our intelligence layer. The real-time anomaly detection. For this, we have used two models, that is isolation forest and seasonal hybrid ESD. The isolation forest is unsupervised model which creates isolation trees to detect the outliers in metrics like latency, CPU or error rates. It flags anomalies without prior training, critical for dynamic systems. The second model, which is SHESD, adapts to daily weekly patterns. If service memory usage spikes abnormally at 2 am, it knows it's a false alarm. The second thing in intelligence layer is predictive forecasting. For this, we use Prophet model, which is a time series model. It trends and seasonality, predicts metrics like database CPU or API latency hours in advance. Example, payment service will hit 90% CPU at 3 am, scale now. This will be a kind of forecasting from our predictive forecasting model. The model is trained separately for different environments, that is, an environment aware thresholds. Model trained separately for per environment. A 500 millisecond delay might be normal for Azure, but critical in Google Cloud. Our solution also provides adaptive learning. It restrains models weekly using fresh data, adapts to code deployment, infrastructure changes, or traffic shifts. When anomalies are detected, Kubernetes horizontal pod autoscaler scales microservice instances dynamically, like spinning up new pods when AI detects a surge in HTTP errors. Our self-healing engine then recommends precise action, roll back a faulty deployment, reroute traffic to healthy cloud engines, or restart unstable instances. Finally, Kibana dashboard correlates alerts to traces. Click an alert to see, for example, how a memory leak in an instance 5 on-premise triggered API failure across AWS, Azure, and GCP. The system we have tried to build is not just a monitoring, it's a self-learning system. It understands our architecture, predict failure, and guide fixes as well.